Okay, we're going to review how to simplify radicals, how to multiply radicals together, and then how do we divide radicals, also known as rationalizing the denominator. Okay, first one here, we have 8 times the square root of 192. Now, there's not a times sign in between these two, but we know that's what's going on between those. So the 8 is out of jail. We can leave it alone, but the 192 is in jail. So we have to try and factor tree that one. So we want to factor tree this, and I've just brought the white list up here. These are our perfect squares. And we want to know what goes into 192 off our white list. So we want the biggest number. So I'm just going to take 192 divided by 4. And I got 48. So there's a number. 4 automatically is one off of our white list that'll work in there. But I'm not sure it's the biggest one because 48 can factor some more off of our white list here. So I'm going to keep going. I'm going to do 192 divided by 9. And when I do that, I get a decimal, so I know 9 isn't going to work. And then I'm going to take 192 divided by 16. And when I do that, I get 12. So I found another number off the white list, so perfect square that'll go into 192. The deal is, though, is that 12 can factor some more off of our list. So I know that 16 is a number, but it's not the biggest number. So I'm going to keep trying here. I'm going to go 192 divided by 25. That gives me a decimal, so I know 25 is not going to work. And then I'm going to try 36. So 192 divided by 36. That gives me a decimal again. So I know 36 isn't going to work. You should be trying these on your calculator. Next one is 49. So take 192 divided by 49. That gave me a decimal as well. So I'm going to try a different number. Next one is 64. So 192 divided by 64. That one gave me 3. Now, I think we might have our biggest number here because 3 isn't going to factor down anymore. So I think 64 is the biggest number off the white list or the perfect squares that divides into 192. So 64 goes in there 3 times. Now, what do we know about the square root of 64? Well, the square root of 64 is 8. And since it's on the list, when I take the square root of it, I don't need the jail anymore. I don't need the square root sign. The 3 can't break down anymore, so it stays in jail. Now, I can't forget about this first number that we had out front here, so it's got to come down here and join the party. And these guys were getting multiplied together, so I'm just going to multiply 8 times 8 to get 64, square roots of 3. Okay, division problem. The first thing you want to look for is the numbers in jail. Can they divide? So 3 is in jail, 2 is in jail. Can 3 divided by 2 reduce down to an integer? And of course the answer is no. So I need to get rid of that square root of 2. That's not allowed in our denominator. So we're going to rationalize this by multiplying the denominator by the square root of 2 and the numerator by the square root of 2. So in our numerator, we have the square root of 3 times the square root of 2. Both of them are in the square root. They're both in jail, so they can play together. So this turns into 3 times 2, which is just going to be 6. So we have the square root of 6 in our numerator. Now, in the denominator, the 5 was already out of jail, so it's already going to stay out of jail. We don't mess with that just yet. And then we're just going to take the square root of 2 times the square root of 2. These guys are both in the square roots or in jail, so they can play. So 2 times 2 is 4. And then we just try and reduce down. So looking at my numerator, square root of 6, I'm going to go over to my list of squares again. Are there any numbers in here that will divide by 6 divides by those numbers to give me an integer? And of course the answer is no. So I know the square root of 6 can't reduce down. Our denominator, we still have that 5 out front. That's okay. What do we know about the square root of 4? Well, 4 is on my white list. It's a perfect square. So the square root of 4 we know is 2. It breaks out of the jail. So my final answer on this one will be the square root of 6 divided by 5 times 2, which we know is 10. Final answer. And then our last problem, we're just going to multiply radicals together. So the numbers out of the jail can multiply together. The numbers in the jails can multiply together. So the numbers outside of the jails can multiply together. 3 times a negative 3 is negative 9. And then the numbers that are in the same jail can multiply together. So square root of 4 times square root of 2 is square root of 8. And then we would just need to see if we could break this down, which this one kind of seems a little silly because the two numbers that work are 4 and 2, which are the two we multiplied together. But if we didn't catch it right off the bat, we can catch it here. Square root of 4 is 2 because 4 is on my list of perfect squares. And then this square root of 2 can't break down anymore, so it stays in the jail. And then we cannot forget about the -9 that we had out front. He's going to come down here and join the party. And then we would have a -9 times 2, which is a -18, square root of 2. That's your final answer right there. Now, some of you on this problem maybe recognized right off the bat that this could have reduced down. So if you chose to do that, you would have had 3 times, the square root of 4 is 2. So that just would give me 6 times a -3 times square root of 2. And again, the 6 and the -3 are out of jail, so they could have played, giving me the -18. And then that would just multiply by the square root of 2, which is the exact same answer we just got. So either way works.